An exponential equation is an equation where the variable is in the exponent. In other words, the variable that you're trying to solve for is in the air. If you are able to get a common base, then you can set the exponents equal and solve. If you are unable to get a common base, then you must use logarithms to solve those exponential equations, and that's another video topic. So let's take a look at this first example. I have a base of 4 and 32. And what I need to do is to make both of those be the same number raised to a power. So 4 is 2 squared. Bring down the 4x plus 6. Now 32 must also be 2 to some power. That's 2 to the 5th power. Now that I have the same base, these 2's, I'm going to drop those, and then I can set these exponents equal. And you have a nice equation to solve. So distribute, and that'll be 8x plus 12 is equal to 10x plus 5 when I distribute that. Subtract your 8x over to have 2x. Subtract your 5 over to have 7. Divide by 2. And x is equal to 7 halves, or a decimal of 3.5. Okay, let's take a look at the next example. In this example, I have 5, which can't be anything but a 5, so we know that that's going to stay 5 to the 3 minus 2x power. Now, we have to take 125 and also make that 5 to some power. Either you will know that, or you can go to your calculator and just start playing with numbers. 5 to the 1st, 5 to the 2nd, 5 to the 3rd, 5 to the 4th, 5 to the 5th, and so on until you find that number. It happens to be 5 to the 3rd power. Bring down your x minus 4. Now that we have the same base, drop those bases, set those exponents equal, and you just have a nice equation to solve. Bring down the 3 minus 2x equals, distribute, and you get 3x minus 12. I'm going to add my 2x over, so I have 3 equals 5x minus 12. Add your 12 over, so you have 15 equals 5x, and x is equal to 3. Let's look at example 3. This time I have 9 equals 1 over 243. So I'm thinking about a base, and with 9, it's pretty obvious that that's going to be 3 squared. Now, I need to take this 243 and think about what power that is to 3. Again, 3 to the 1st, 3 to the 2nd, 3 to the 3rd, 3 to the 4th, 3 to the 5th. Just keep playing with those numbers on your calculator until you find it. And it happens to be 3 to the 5th power is equal to 243. So 3, and we know it's a 5th power to get 243, but here's a catch, and here's where you want to be careful. Do you notice this is in the denominator? The way that a number gets from the numerator down to the denominator is with a negative exponent. So when you see that your number is in the denominator from the numerator, you have to make sure that you know a negative exponent is how it got down there. Then bring down your 2x minus 1. We have the same base. Drop those bases, and let's set those exponents equal to each other. So this time, I will just bring down my 2 is equal to, distribute that negative 5, watch your signs, negative 10x plus 5. Subtract your 5 over, so 2 Subtract 5 is negative 3 equals negative 10x. Divide by negative 10. And so negative 3 divided by negative 10 is positive 3/10, or maybe 0.3 if you prefer to write it as a decimal. Let's take a look at number 4. All right, so looking at number 4, we've got to think about what base that we're going to get these equal to. So I'm thinking 6 squared is 36. So that's the base that we want. So 6, but it happened again. This is in the denominator. Since that is 6, squared is the 36, but because it's in the denominator, you have to know that the negative exponent is what made it get down there. So then bring down your 3x minus 5 equals, and then again, just kind of go to your calculator, start playing with those numbers, and you'll see 6 to the 3rd power is what gives you 216. Now that you have the same base, drop those exponents. Make sure you distribute your negative through very carefully. Set those equal to each other, and you'll have your answer. So that's negative 6x plus 10 is equal to negative 3x plus 15. Now we need to solve this equation. It's your choice if you want to bring the 6 over or bring the 3 over. I think I want to bring the 6 over to avoid negatives. So 10 is equal to 3x plus 15. Subtract that 15 over. Negative 5 equals 3x. Divide by 3. And you get x equals negative 5/3. Okay, let's take a look at example 5. So I'm thinking about a base that both of these can be raised to powers 2. Now, I know that your first instinct might be to think, well, 16 is 4 squared, and that's a true statement. But 128, if you start saying 4 to the 1st, 4 to the 2nd, 4 to the 3rd, 4 to the 4th, none of those are going to get you 128. So therefore, we can't use 4 as our base. We're going to have to go back down to 2. 16 is 2 to the 4th power, and 128 is 2 to the 7th power. Okay, now that I have those same bases, let's drop them and set the exponents equal and have a nice equation to solve. So that will be 14x minus 14 when I distribute those through, and then I'll distribute here and have 20x plus 4. I'm going to subtract my 14x over. Make sure you keep your face with your body right there. Don't lose your sign. So negative 14 equals 6x plus 4. Subtract that 4 over. So negative 14 minus a 4 is negative 18 equals 6x. Divide by 6. And x is negative 3. Okay, let's take a look at example 6. When I look at example 6, I can see pretty easily that my base is going to be 7. So 49 is 7 squared. Bring down your x. This is just going to stay like it is. All right, so we know we're going to drop those 7s and we're going to set those exponents equal to each other. When I do that, I'll have 2x equals x squared minus 15. Well, hopefully you recall that when you have an equation like this, x squared, that you need to set it equal to 0 and try to factor it. So I'm going to subtract the 2x over. So come over here and subtract him over. And I have 0 is equal to x squared minus 2x minus 15. So I have a really nice, easy little trinomial that needs to be factored. So the way I factor is I think what multiplies to get this, what multiplies to get this, But what adds to get that? Sometimes I'll call them a little ma'am problem. So x squared would be x and x. Those are my only options. 15 multiplying but adding to get 2 would be a 5 and a 3. But look at your middleman. Your middleman is negative. So we need the bad guys, the negative guys, to win. So negative 5 and positive 3 adds to get 2, but negative times positive multiplies to get negative 15. All right, set them each equal to 0. And when you do, you'll subtract over your 3, and you'll add over your 5, and you'll get x equals 5 and x equals negative 3. Let's look at example 7. As I look at example 7, the base, pretty obvious again, that it's going to be 5. 5 squared is what gives me 25. Now don't forget to bring down your x squared. 125 is 5 to the third power. Don't forget to bring down your x plus 3. I have the same base, so drop those bases, and we're going to set the exponents equal to one another. So that says 2x squared is equal to distribute 3x plus 9. Again, because of this squared and that trinomial, I'm going to set it equal to 0 and factor it. If it doesn't factor, we could use the quadratic formula, but this one's going to factor. So let's subtract 3x, come over here and subtract it from this side. Subtract 9, come over here and subtract it from that side. None of these people are friends or like terms, so let's just bring them like we see them. 2x squared minus 3x minus 9. Again, we need to multiply, add, multiply. The only thing that multiplies to get 2x squared is 2x and x. We need to multiply to get 9, but our loops, as you're going to see, our loops still have to add, that middleman still has to add to get to be negative 3x. So the choices for 9 are 9 times 1 or 3 times 3. Let's try 3 times 3. All right, let's check our loops. That loop is 3x. That loop is 3 times 2 or 6x. And sure enough, I can make a 3 and a 6 get to be a negative 3 if I let the negatives win and the 3 be positive, because 3 minus 6 adds to get negative 3. So I'll put my signs on there. That's a positive and that's a negative. And I still have a positive times a negative multiplies to get a negative 9. All right, let's set each of these equal to 0. And when I do, I will subtract my 3, divide by my 2, and get negative 3 halves, which is also a negative 1.5, depending on which way you want to write that, and add your 3. Okay, last one. You're doing great. So we need to get a common base, which is 2. 2 to the 6x is just going to bring on down. Then we know 2 to the fourth power is what gets 16 equals, and that's 2 to the third power, and bring down your x plus 2. Now, right here, we do have a little something we have to do that's a little bit different. This problem may be a little more advanced than some of the others, but I want to try to give you samples of everything, from the easier ones all the way to the difficult ones. When you have the same base and you have your exponents, you're supposed to add those. Think about this. If you had x to the third times x to the 10th, wouldn't your instinct say bring that x over and add those exponents? That's the same thing here. You're going to take that 2 and you're going to add those exponents. Just like you did here. Keep that base, add those exponents. Keep that base of 2 and add those exponents. Now that I have the same base, drop those bases, set the exponents equal, and solve your equation. So 6x plus distribute 12 minus 4x equals 3x plus 6. Collect your like terms. 6 minus 4 is 2x plus 12 equals 3x plus 6. I'm going to subtract that 2x over, so 3 minus 2 is x. Then I'm going to subtract that 6 over there, and 12 minus 6 is 6. If you need more practice on solving exponential equations by finding a common base, be sure to watch my practice worksheet video on this topic. There you can watch me work more examples. You can even pause the video, try the problem on your own, and then start it back to check your answer. If this video was helpful, please like and subscribe to my channel. This allows me to continue to grow the channel so I can help build your math esteem one problem at a time. See you later.